we're going to continue. We're going to go back to Newtonian mechanics, except now we're going to look at a systems approach for objects. We're going to start with Newton's third law. So if we have two things that are hitting each other, goats in this case, A hits B, B hits A. All right, each force is always accompanied by a separate force of equal magnitude. And all it means is that if A hits B, B hits A. The negative is just a directional component. Notice, one force acts on object B and the other force acts on object A. They have to act on two different objects. That's very important. So one force on object A, one force on object B. I think that one of the easiest ways to look at this is an example. So I've got these two boxes, and we want these boxes to remain stationary to each other. I'm going to pull with some force F. All right, well, I've got two objects, so where's a great place to start? Force diagrams, you're right. So let's take a look at the force diagrams. Well, we know each box is going to have the force of gravity acting on it. And since they're not falling through each other, we know there's going to be a normal force. Now here comes that force pair we talked about. What is causing the normal force on B? What is pushing against it? And the answer is block A. So the normal force of B on A and the normal force of A on B are right here. Notice they act on two different objects. Two different objects, equal magnitudes, and opposite directions. Force on block B points up, normal force from block B on A points down. Well, we'll show you how in a second. So let's look at force on block Y. Same way, not accelerating the Y direction. And I can get an expression for the normal force on block A. Alright, that's good. And then I can get the normal force on block A. Now that would be useful if I had friction between the surface down here, but I don't. So right now that was just kind of fun. Alright. And then we look at the x direction. So I've got the force in the x direction causes the acceleration of block A in the x direction. So the force I apply minus block B rubbing on A equals the acceleration. Use that expression I derived earlier, and I get the force is equal to my applied force to keep them from slipping is equal to this. But let's go back. We don't know this AX. Is there any way I can relate them? Of course! Because I know that the acceleration of block A and the acceleration of block B have to be equal because the blocks are stationary to one another. So when I incorporate this, I can use this A on B right here, and I can get an expression for the force applied for them to stick together. Wait a minute, this looks like force and mass of A plus mass of B, and then, oh, that's just the acceleration in the x direction. Interesting. So let's take a look. There's another way to look at this, and that's with the systems approach, which is where we're going. So with the systems approach, I look at it, here's my system, and I look at the external forces, in which case my external forces are just mass of the system, mass of A plus mass of B. All right. Oh, wait a minute. This is the acceleration of the system, and MA plus MB, that's my effective mass of the system. I calculated this Fx from before, but all this is saying is that my external force on the system is equal to the mass of the system, the effective mass of the system, times the acceleration of the system, where I define my system as block A and block B. We're going to delve into this more in the next video. I hope this helps. Please come to class with any questions, and I will see you in class.